In this video, we're going to take a deeper look at the various producers and consumers in an ecosystem. And for the sake of diversity, no pun intended, we're going to look at a marine ecosystem, let's say an estuary. And an estuary generally refers to a place where you have a river coming to where the tide comes. So it's a mixture of both the fresh water from the river and the salt water from the sea. And they tend to be very productive from an energetic or a biomass point of view. So if I were to make an energy pyramid for, let's say, this estuary that we're looking at right over here, it might look something like this, where at the bottom layer, these are the primary producers. And we've studied this in other videos. Primary producers. In a marine environment, these would be things like phytoplankton. Phyto, they're doing photosynthesis, and they're plankton. Plankton is a general term. It comes from the Greek for drifter. This right over here is seagrass, also something that can photosynthesize. And this right over here is algae, which I'm sure you have seen when you've gone to the sea or you've gone to a pond of some sort. And when we think of photosynthesis, we often talk about terrestrial things, things like trees, but a lot of us don't realize that 50%, that's a big number, of Earth's organic energy is produced by floating photosynthesizers like phytoplankton and ultraplankton. So things like this, things that you oftentimes don't see, that's 50% of Earth's organic energy. So these things are really, really important. And as I mentioned, estuaries tend to be quite productive. They actually are comparable to things like rainforests. Now, for the sake of making things tangible, this being an estuary, which is very productive, let's imagine that the net primary production from this first layer, we could think about it in terms of biomass. Maybe it's about 2,000 grams per square meter per year. Or we could think about it in terms of calories. This would be approximately equal to, it depends on the type of biomass you're talking about, but you have roughly 4 kilocalories per gram. So that would be roughly 8,000 kilocalories per square meter per year. That's the net primary production of this first layer of the primary producers. Then what would we see at the next layer? Well, we know that not all of that energy can be used by that next layer, which would be the primary consumers. And there's some examples here, and it's much more complex than what this pyramid depicts. But what we see here, these are zooplankton, which are really, you could view it as animal plankton. It's a large category of things. They have the word plankton in it, so they kind of have to go with the flow of whatever the tide is doing, whatever the currents are doing. Another primary consumer could be a fish like this royal blue tang that might be eating plankton. And the net energy that's available to the layer above that is going to be a small fraction of the net primary productivity of that first layer. Typically, it's about 10%. So there might be, instead of 8,000 kilocalories, 10% of that, we'd be talking about approximately 800 potential kilocalories per square meter per year that would be available for the next layer. Now, you might be saying, hey, where are all the other calories going? Well, remember, even in this first layer, we said this is net primary production. The gross would be even higher. These photosynthesizers had to use that energy for things like respiration. And even on the net basis, the reason why so much gets lost when you go to the next layer is these animals here, they have to use that energy to live, to do things like respiration. And a lot of this energy is just not consumable by the next layer. So it can become detritus, which is, you can just think of this biomass that is just laying around. Energy at every level can be lost to heat, can be used for movement, for growth. So you can imagine you get to a level above that. We could call this secondary consumer. And this is just a picture of a grouper. Marine ecosystems would be much more complex than this. But the net calories after the groupers live their life, et cetera, that is available to the level above that would be roughly, again, 10%. So maybe 80 kilocalories per square meter per year. And then at least in this example, at the top of this pyramid, we have an apex predator that is a shark. What is available after the shark's done all of its business is roughly 10% of that. So approximately 8 kilocalories per square meter per year. And so the important thing to think about is whether we're talking about terrestrial or marine environments, you have this significant loss of energy as we go from one layer of the pyramid to another. But at the same time, everyone has to be using energy, and the energy has to come from someplace, and we've covered in other videos. It's coming from sunlight, and there has to be this continual process of being able to take that inorganic energy, turning it into organic energy, and then you have significant energy loss, but that energy keeps flowing up this pyramid. And we're not even done, because even the apex predators, at some point, they're going to die, and then they have tissue, and in that biomass, there's energy that could be consumed by others also to release nutrients that could be used by these initial primary producers. And that's where things like detrivores, and this is a starfish, which is a detrivore, things that can actually consume dead matter, they are really useful, because then they can bring nutrients back to primary producers and to others. And when we're talking about an aquatic environment like this, and we're talking about photosynthesis, one question you might be asking is, wait, well, where can photosynthesis occur? If you go deep enough, it's going to get quite dark. And you'd be right if you were asking that question. When you think about marine environments, there's something known as a euphotic zone, which is the zone where it's shallow enough to get enough light so that you can actually do photosynthesis. And so it's no coincidence that things like estuaries, things where the water is shallower, where there's going to be more nutrients and where there's going to be more light, that you actually have more primary production.